Today we're going to be reviewing the first 4 sections of Chapter 8 because this is going to be on your test, which is coming up in several days. So what I would suggest that you do is that you take notes on this, make sure that you are following along, and you will have a Schoology assignment where you are going to input not only the answers for this, but then there are a couple problems that you will have to try by yourself. So let's get started. This was from the very first lesson, lesson 8.1. We're going to name the polynomial based on the number of degrees and terms. So we have 9x squared minus 8x plus 1 plus 3x. Anytime I'm asking you to identify the degree and the number of terms, the first thing you're going to want to do is you're going to want to look to see, are there any like terms? So if there are, we have to combine those first before we start identifying different pieces. Notice that in this problem, I see a negative 8x and a positive 3x. Those are like terms, so they need to be combined. Remember, when you combine like terms, you do not add exponents. So negative 8 plus 3 is negative 5, and that x stays as it is. Otherwise, the 9x squared and the positive 1 are also going to be as they are because there was nothing to combine with that. So really, this is the polynomial that we now need to focus on when we are identifying the degree and the term. So if we start with the degree, remember the degree means that we're looking at the exponent, and I want the biggest exponent of the variable. We either then would have degree 0, 1, 2, or 3 based off of the vocab. And so if it's degree 0, that makes it a constant. If it is degree 1, then we are dealing with a linear. Degree 2 would be a quadratic. Degree 3 would be a cubic. Notice that in this, we have degree 2 because that's the biggest exponent with my variables. So it looks like we have a quadratic. As far as the terms go, there are 3 of them. We have when you have a single term, 2 terms, and 3 terms. So when you have 1 term, we call that a monomial. 2 terms is a binomial. And 3 terms is a trinomial. You count up terms by looking at what gets broken up by addition and subtraction signs. Notice that 9x squared is 1 term. 5x or negative 5x is a second term because it's different than the squared term. And then 1 is different than the other ones because we're dealing with no variables at all. So we have 3 terms, which makes it a trinomial. So hopefully that vocab is coming back to you. Let's look at something else from that first lesson, 8.1, placing the polynomial in standard form. Remember, standard form means that I'm going from the biggest exponent to the smallest. So we're looking at variables and its exponents. Notice that the first term, 8x, really has an exponent of 1. Then we have 10x to the 5th, so 5 is that exponent. We have this negative 2x cubed, so 3, and then plus 11. Because that doesn't have any variables, that would have to be the smallest. So anything that doesn't have a variable would be last. So that means that that plus 11 is still going to stay at the very end. Hopefully we notice that 5 is the biggest exponent. It's got a positive 10 in front, so we'll have 10x to the 5th to start us off. Then the next biggest exponent would be a 3. Notice how we have a negative 2 in front, so we'll have minus 2x to the 3rd. Then we want to deal with the x that has just a degree 1. That 8 is positive. And then once again, the 11 goes last because there are no variables there at all. This would be my answer in standard form because there are no like terms, and it goes from the biggest exponent down to the smallest. Also in lesson 8.1 was adding polynomials. Notice that I'm dealing with addition because there is an addition sign breaking up these two parentheses. When you are adding polynomials, you do not add exponents, okay? Well, basically, anytime we are adding polynomials, we are combining like terms. So right off the bat, I noticed that the x squared in the first parenthesis technically has a 1. I see that there is a 5x squared in the second parentheses. Those are like terms. I do not add exponents. I just add the numbers in front. 1 plus 5 is 6, and that will stay x squared. I see that there is a negative 3x in the first parenthesis, and there is a positive 8x in the second. I once again want to combine like terms by just adding the numbers in front and keeping the x as is. So negative 3 plus 8 is positive 5, and the x stays as it is. There is a positive 9 and a negative 14 in each of our parentheses. Those are like terms. Negative 9 plus negative 14 would give us negative 5. Notice that my answer is in standard form. It goes from the biggest exponent down to the smallest. This is my answer. Also in lesson 8.1 was subtracting polynomials. We do have to do a little bit more work, but just like the adding, we do not add exponents. The exponents stay as they are. Okay, but in this case, because there is a subtraction sign breaking up my terms, the first thing I'm going to have to do is distribute the negative to everything in the second parenthesis. So that 7x minus 1 will stay exactly how it is. You don't really have to write the parentheses anymore. Now I'm going to distribute the negative. So negative times 10x is negative 10x. Negative times 6 is negative 6. Once I've distributed, now I'm just back to combining like terms like we did in the last problem. I see 7x and negative 10x. So I get to add the numbers in front and keep the x as it is. Well, 7 minus 10 is negative 3, still with the x. I have a negative 1 and a negative 6. Those get added together. Negative 1 minus 6 is negative 7. Once again, notice that my answer is in standard form because it goes from the biggest exponent down to the smallest. So now it's your turn to try to do this one on your own. So make sure you pause the video, write down your answer so you can put it into the Schoology assignment. Moving on, we've got lesson 8.2. We multiplied polynomials in this. So in this case, we have 8x cubed times x squared minus 5. When multiplying, this time we do add exponents. So as long as the base is the same, I'm going to keep the base and add the exponents. But any number that isn't an exponent gets multiplied together. So there is technically a 1 in front with the x squared. So I'm going to distribute. 8 gets multiplied by 1. So 8 times 1 will stay 8. Because there is an x to the third on the outside and an x squared on the inside, those x's are the same, so it stays x. But like I just mentioned, we are going to add the exponents. 3 plus 2 is 5. I'm going to bring down that subtraction sign, and now I'm going to distribute that 8x to the third times 5. So 8 times 5 is 40, and that x to the third also gets distributed. Because there are no x's with the 5, the x to the third is going to stay as it is. These are not like terms. 5 is bigger than 3 as far as exponents, so it is in standard form. So this is my answer. Also in lesson 8.2, we talked about factoring out the GCF. So remember, when we're looking for a GCF, we're looking to see what numbers do they have in common, the biggest number do they have in common, and what's the biggest amount of variables that they have in common. Because 10 is smaller than 15, but there's no way to multiply 10 times something to get 15, I'm going to start breaking up 10. 10 is the same thing as 2 times 5. 15 is the same thing as 3 times 5. Notice that both of those numbers share a 5. So my GCF will contain a 5. When I'm looking at the variables, I'm looking for the smaller exponents. So once again, if you want, think of x to the third as x times x times x. You can think of x squared as x times x. Notice how there are 2 x's in the first term and 2 in the second. So that's how many that they have in common. Once again, between an x to the third and an x squared, the 2 is smaller than the 3, so the 2 is what's going to be a part of the GCF. If I look at the y's, we've got technically 1 y in the first and 6 y's in the second. So similar to the x's, remember, I take the smaller exponent. 1 is smaller than 6, so we'll have 1 for my GCF. But now it says factor out the GCF. So the GCF is not my final answer. What we'll do then is in parentheses, put whatever was left over. Remember, 10 we don't have to look at because that got broken up into 2 times 5. 5 got taken out, we still have a 2. When I look at my variables, x to the third, well, 2 of those x's moved out, but there's still an x left over. As far as the y is concerned, it got moved out, so there are no more y's to put underneath in the parentheses. I'm going to bring down that subtraction sign and move on to the next term. 15 we can ignore because that's 5 times 3. The 5 got taken out, but there's still a 3 left over. The x squared we can ignore because we took out x squared. Y to the 6th, we are going to have some y's left over. Now remember, if I took out 1 y, that means that there are technically 5 left over. So this would be my final factored answer. Once again, I want you to pause the video and try this. You are multiplying. Make sure you put your answer in standard form. All right. So then we have the last lessons that were kind of mixed together. So 8.3 and 8.4, we want to multiply polynomials. This time it was a binomial times a binomial or a binomial times a trinomial. And what we talked about is that there were 2 different ways to do that. There was the distributive property or distributive method, and there was the box method. So I'm going to show you both ways, but remember, you get to do whatever you have a better preference of. So if you like to distribute, then do that method every time you multiply. If you like the box method, do that one instead. But to distribute, remember, that means that I would break up the first one and I would keep the second one the same. So my setup would be 2x getting multiplied by what I'm keeping, which is the x plus 7. I go back to what I'm breaking up, which was -3, and that gets multiplied by what I'm keeping. So I would distribute, and remember, when I distribute, I'm adding exponents. So this first one, 2x times x is 2x squared. 2x times 7, I multiply the 2 and the 7 to get the 14, and I get to keep the 1x. Now I'm going to distribute -3. -3 times x is -3x. -3 times 7 is -21. Notice that there are a couple of like terms. When we combine like terms, we do not add exponents. So that means that I keep the 2x squared. 14x minus 3x would give me a positive 11x, and I still have minus 21. And this would be my answer. So that's the answer that we should get when we do the box method. So if you prefer the box method, remember this was a 2 by 2, which means that we should have 4 boxes. So I'm going to create my 4 boxes. Where remember, with my boxes, I always break them up with addition signs. One of the parentheses goes on the top, so I'm going to do 2x, which means the negative 3 goes after the addition sign. And then the second parenthesis I'm going to put on the side, so x plus 7. Remember, these terms are getting multiplied to fill in the boxes. So if I start with the top left, one side of the box is 2x, one side is x. 2x times x is 2x squared. The top right, one side is negative 3, one side is x. Negative 3 times x is negative 3x. Bottom left, one side is 7, one side is 2x. When I multiply 2x times 7, we get 14x. Bottom right box, we have negative 3 for one of the sides, 7 for the other. Well, negative 3 times 7 is negative 21. Notice that with inside the boxes, there are a couple of like terms. So everything else is going to stay the same. So we'll start with the 2x squared. Like terms, we do not add exponents. 14x minus 3x will give me that positive 11x, and then we still have negative 21. Notice how, like I said, we got the exact same answer, which is why it doesn't matter which method you choose. Pick one to then multiply. Okay, so you decide which method you like best. Try this one, and then make sure that you put your answer in the Schoology assignment.